Well, thank you everyone for joining. And for the first hour of this session, we are going to go through filters and filter applications. So types of filters. So we have power entry modules, which we will call PEMs. And basically these are just IEC inlet applications. And then it has multiple options, including shielding, fuses, and switches. We also have single phase filters for single phase power line applications, and these have multiple termination methods, could be fast on tabs, nut and bolt, and terminal blocks. And then we also have three-phase filters for three-phase power line applications, and again, has the same multiple termination methods. And then I know I invited Jay Bander, my product engineer, on here to kind of go over what a conductive emissions standards is, because this is key for filter design-ins.
So for conductive emissions, what it is a lot of products have to meet this so that they don't cause interference to, let's say, other products, like the TVs, radios, all that good stuff. And they're more common in Europe. FCC Part 15 is predominant for the US. And a lot of times it's based on their category of what they made their product for. And so what they'll have to do is go and take their product and test. And there's radiated and conductive. We only deal with conductive because radiated solutions might be they need to put their whole product in a metal housing, or there's other things they have to consider, where we're basically dealing with the power line and what noise might be coming out, dealing with motor drives, switching power supplies. Anytime you're turning anything on and off fast, kind of puts a pulse back out onto the power line. And you'll also be able to get, noise coming back out. And because of that, also being a sharp thing, you'll get harmonics of it. So that'll cause it to go higher in frequency. What we're looking at is what Part 15 of the FCC and the harmonized one for EN 5522. And there's two of them there, Class A, Class B. Class B being for like your household. Class A for the more of an industrial environment, meaning they have more noise. And then just quasi-peak and average have to do with how the noise is measured and how it presents itself when they're sitting there and looking at it. Because if the noise just shows up like one time but real strong, it'll fall in one category. If the noise is redundant in one spot all the time, that's where the average noise comes into play, and that has a different spec level basically. That's the base of it, basically. Like I said, a lot of times, them being our customers, if they're not really sure how much noise their product has until pretty much when they're ready to go to testing, we seem to be always a band-aid or a solution to their problem, because if they really knew it was there, they'd be trying to solve their noise issue as effectively as they can, and not trying to deal with it right at the power line where they're dealing with the full amount of current that their product might draw, being 5 amps. 10 amps, whatever. If you found out where your noise truly was and you were able to, suppress it, it would never get back onto the power line.
Because the next two slides just show an example of a system without a filter and with a filter. So you can see, not to interrupt you, Jay, but you can see like the Class B conducted average. So there's the system without a filter. And then Tony, if you go to the next slide, this is test data once the system added a 3VS1 filter installed. And as you can see, the noise levels are below
the red line is the spec itself. The other line you see below it, the black one, is like a 6 dB margin. The customer decided on their own that they felt they were in by enough with that. But once again, we're just trying to show you what it ends up helping them with. And like I said, they end up calling the shot because they're trying to put in the minimal amount of filtering that they can, because the next to get a little better performance might actually be a larger filter in terms of physical size and another series. And they're fighting costs too. So this is what we usually deal with.
So here we're going to start kind of going over the product portfolio that we have that helps customers solve these conductive emissions issues that they see in the field. So this is the overview of our inlets and power entry modules. So this is a very high level view, but the purpose of this is once you get this PowerPoint after this presentation, this is something you can put into or save to your computer to show customers to kind of get a feel for what they actually need. But going from left to right, we kind of work from, the first series up to the full extent that covers, switches, fuses, et cetera, et cetera. So we do offer unfiltered inlets. So these are just basic full line of popular AC receptacles. So these are different plug types. So you have a C13 and a C14 inlet type up to 15 amps, and then C19 and C20 inlets rated up to 20 amps. But again, this is just for, there's no filtering here. It's just basically a power inlet module, but it's good for equipment with replaceable power cords. And then with this, customer can control the cord options due to the different interfaces. And then we go to unfiltered shielded inlets. So this offers the RF shield, low leakage currents for, you can do patient, non-patient medical equipment, has the same power cords. You have a C14 up to 15 amps and a C20 inlets up to 20 amps. And again, equipment with replaceable power cords. And then devices that also have radiation issues. And this is, so you have the SR series and the unfiltered. The SRB, again, same thing as the SR series, just the B, you get the RF shield here. Filtered inlet. So I have this listed as kind of an AFG application here because filtered inlets, we've started to see some design-ins with these on charging stations for like AMRs. So multiple filter performance levels. It has the low leakage options for medical, has a snap-in flange mounted versions. Again, has the different cord interfaces. So you have like a C13 and a C14, C18 up to 15 amps, and then C20 up to 20 amps. And again, replaceable or equipment with replaceable power cords. And then devices, here's where you start to see the devices that need to meet a conductive emissions standard. And as we keep going along, so it keeps evolving. So now we have filtered inlets if the customer needs a fuse. So we have power entries with fuse holders, multiple filtered performance levels, low leakage for medical, snap-in flange mounted versions, and this version goes up to 10 amps. And then same thing as the filtered inlet, just if a fuse is required. And then we have filtered inlets with fuses and with switches. So again, power entries with switch, multiple performance levels, low leakage, snap-in flange mount, up to 15 amps, and then same thing, just equipment with replaceable power cords, and then if a switch is needed. And then you have the power entry module here, what we call the P series. So this is the most versatile PEM with and without a switch, single or dual fuse, different shield options. Basically, this is the best of all the features of all the previous families combined into one. Low leakage for medical, multiple filter performance levels, and then this goes up to 10 amps. And then this covers everything. Again, equipment with replaceable power cords, devices needed to meet conductive emissions, if a fuse is required, if a switch is needed, and for medical equipment. And we have a J and a P series, but P series is by far our highest runner part, and you have the most versatility with it. And what I'm going to do here real quick is kind of dive a little bit into the P series, just because it is the all-encompassing product and you can really solve all the customer's needs with this one option if they need a power entry module. So a lot of these are snips out of the catalog that you can reference, but the easiest way, you'll see a lot of P series parts. They all have this smart part number configuration. So you build the part number using a form, fit, or function of the position. This is also how, if you come up against a Schurter or a Schaffner, you can kind of work backwards and come up with the closest, I wouldn't say it would be an exact cross, but the closest product that TE would have. So the main things you want to look at is the form, so the physical size, or the panel cutout that's needed, the fit, which would be the mounting style. So we have a PM, PS, and PE, so it's vertical, horizontal flanges, or if there's no flange, it would be the PS version. And then the function, we'll dive into that a little bit here, but using the datasheet to identify customers' needs and create a part number. So the P series is UL, CSA, and VDE certified. So again, the P series, we call it the Chameleon because it offers the most popular features in a small footprint design. As the first 10 amp module to provide all 5 power entry functions in one compact design. The Chameleon module readily adapts to its environment and the needs of the international markets. So again, it's got a snap-in or flange mounting. It uses a industry standard C14 power inlet, North America and metric fusing capabilities. You have a 2 voltage option or selection option, and then optional on-off switch. Filter options for general purpose, medical, and high performance EMI filtering. So if you have any customer needs for a power entry module, you can probably meet the needs with the P series by itself. So the P series itself has 4 filtered and 1 non-filtered option. So as you go through the catalog, you'll see the different models there. So the S models for general purpose. H, usually with Corecom, if you see an H in the part number, that usually signifies that it's a medical version, so low leakage. And then L is high performance, Z is high performance for switching power supplies, and then the B option is the non-filtered version. So Jay, you might, if you can help me walk through this with the P series voltage selection option. So you can see a picture down here at the right with the fuse holder. When you turn it over, you can basically select between a 115 volt or a 230 volt option.
And it's probably not as popular as it was before, because a lot of switching power supplies that you'd be driving with this afterwards work from a range of like 90 volts to 250 or something, and you don't need to do anything to your power supply. In the past, some of the first switching power supplies, you still had a little switch or a little like a 2-pin connector that you would either short together or leave open. And that's what the top one is, with the SPMS, where it took the BNC connector and shorted it together. If you were set for 115, and if you turn the fuse holder so 220 is showing out the little window, that stays open. That's what we're representing, those 2 little arrows with the voltage and those ABCD pins. And the dotted line is what the customer's product would be. So all you're really doing is giving the ability for them to know which one is showing, the 220 or the 115, based on BNC being shorted or not. The one below it was back when you used linear power supplies, and you actually had a primary on your transformer, which you had 2 primaries where you put them in either series or parallel in order to change the voltage drop from being let's say from 115 to whatever, let's say 12 volts. And when you wanted to operate at 230, you wanted the 2 primaries in series so that you had a greater amount of windings on the primary going down to, let's say, 4 turns on the secondary to give a bigger voltage drop. And that's what we allowed. And once again, these were designed years ago, and people get a little confused because a lot of times they don't need to really worry about that. So they could buy the version that has no voltage select and still be able to accept any voltage from, whatever they're operating at, 110 or 115 to, all the way really up to 250 is what the product's rated for. And when you buy it without the voltage select, we don't put any writing on the fuse holder, and turning the fuse holder around to either side would not cause any connections between B and C, or between A and B and C and D. But it's there if somebody has it. I do know I had a customer call on something because as we were trying to find parts during our little pandemic, they were trying to switch this over, but they truly were using it for the PRSR1, the parallel series type, because that's the way their product was designed, and they were changing their power supply.
So the P series shield options and fuse holder. The P series offers several RF shield options. As you can see there, the picture in the far right kind of shows the 2 different shield versions. So shield A is I guess what we would call not a partial shield. It says filter shield, but then B has the complete shield, so it covers the entire device on the back end. And then we do have the L and the Z, so a complete metal enclosure is integral to both the high performance of the L and Z models and must be specified by a C in the part numbers. And then down here you can see with the fuse holder, another feature of the P series is the versatile fusing arrangement. The fuse holder can hold 2 1/4 inch by 1 1/4 inch or a 5 by 20 millimeter metric fuses. And then you can also, with the same fuse holder, single fusing is supported with a conversion clip that shorts one of the 2 fuse positions, and that's designated by an S in the 6th part number digit. Now, a single fuse may be reconfigured by the manufacturer or the user to accept 2 fuses by simply removing the shorting clip. So you can see up there in the, was it 1, 2, 3, 4, 5, 6 option, the fuse options. You have the dual and the single fuse. You can always make the customer order a dual fuse, but the fusing clip allows it to be a single fuse as well. So again, that was a high-level overview of the power inlet modules and the P-Series in particular, but this is just to kind of show you some examples of where the inlet and the PEM applications go. So you can see a list there: arcade games, hospital beds, infusion pumps. On the side here, that's a switching power supply up there in the top left. Another example here below that is kind of interesting. We'll talk about single phase filters here shortly, but there's an example there where they're using just a power entry module, no shielding or anything coming in, but then they use a line filter down the road where, I mean, Jay, you can correct me here, but essentially they could have put just a P-Series in there to begin with, or another filter at first, instead of using two parts.
And it would save them their wiring to their fuse and to their switch that look like are at the front panel, sort of like. But that was their call. So. And
then just some other applications where you would see the filter, so you guys can kind of see what to look for inside a device. It's basically the metal can coming in from the outside where the filter would be. And again, LED signage, power supplies, high-end audio equipment, test instrumentation is a very big one. And that would be it for the inlet and PEM application. So similar approach, an overview of all the single phase AC DC line filters here. So again, if the application is not using a power entry model, but running on a single phase power, we have the standard performance, enhanced performance, high performance, all appropriate for AFGs. Key applications can be appliance, test equipment, industrial equipment, and again, just really if it's single phase power coming in, these are the filters that would be used. We do have medical filters in here as well. They meets the leakage current requirements for healthcare equipment and low leakage applications. So it's labeled here as medical, but if it suits an industrial test equipment and allows them to pass the conducted emissions test, don't assume it's just for medical. It could be used in other applications as well. It's just designed towards the medical standards. And the same thing with the lighting filters on the far right, designed towards lighting standards. However, it's still a single phase filter, so it could be used in other applications such as appliance, test equipment, etc. This is just for higher voltage ratings within the series, so 277 and goes up to 480 volts. And then the FBH series does go up to 90 degrees C ambient temperature and up to 20 amps. And again, just highlight below, it's specifically designed for the lighting market, but it can also go to test equipment or into other industrial equipment. So again, single phase line filters, single phase power line filters are designed for frequency invertibles and variable speed drives motors, as well as high performance RFI power lines for medical equipment. Designed to provide the most significant attenuation for RFI noise, and the frequency ranges from 10 kilohertz to 30 megahertz. On the right here, you should have gotten a copy of this before the presentation, but if you're going to take anything away from this presentation, the RFI power line selector chart really helps you narrow down a filter if you talk to a customer and find out it's for single phase line filters applications. So some of you might be really familiar with it. If you're not, just keep it with you. And, as you're talking to customers about filter opportunities, this is a good rule of thumb to at least get to a column with a product series. And down at the bottom there, you can see a good, better, best. So that's, as you work your way down, it's a good filter, it's better, it's the best, basically just for performance levels. But you just walk yourself through the questions. So there's more to it, but this is specifically for single phase. So like for medical applications, if you say yes, you want to start with like an MV series, HD series, HT series, all really depending on where they're seeing the noise. But if you say no, you can kind of work your way down and you can see, for if they're seeing the problem coming out of the equipment or if it's coming into the equipment. And then, you work your way over for switch mode power supplies, yes, no. For the EN550 whatever standard you're looking at. It just really helps you to at least start the conversation and at least get to a product series that could potentially solve the customer's issues that they are seeing. You can also notice too that one thing that's interesting is the filters work both ways. You know, you have coming into or coming out of the equipment, and you can notice that some of these are listed twice. The B series is in both the K series, DK series. So they are pretty universal products that solve a lot of the conductive emissions testing that you'll see in the field. And again, just really helps you narrow down a series in the field quickly. And so overview of the 3-phase AC line filter. So again, similar to the single phase, it's just if the application is running on 3-phase power. So we have basically, it gets down to there's 2 options. There's Delta 3-wire and Y 4-wiring options. So again, you'll kind of see universal applications, you know, compact book form design, low leakage current, multiple terminations, 16 to 230 amps. With the Y, compact dual stage filters, low leakage current, except this one we have 3 to 200 amps and up to 1600 amps in our APS, APH models. So a lot of the AFGs that you guys see will probably be on 3-phase power and robotics, semiconductor machinery. Now, granted, there will be some single-phase applications in there as well also, but again, incoming power, control systems, elevators, escalators, motors, drives, 3-phase applications for these product lines. And then also we did just recently do, as mentioned before, a NPI in this product line. So we came out with 248 part numbers, both Y or Delta wirings. And these products are fully potted, bookshelf type, compact, single and dual stage filters, a whole range of connection styles. So again, terminal blocks, ring and nut, fast on tabs, 1 to 250 amps. Then again, incoming power, control systems, motors and drives, and 3-phase applications. So again, 3-phase line filters, this is their portion of the Corecom filter selector chart. This is an older one. This one does not yet have the new NPI on it. We are currently working, Sam, Jay, and myself, and then once we get it approved, we'll go to marketing. But so we will have an updated one for you, but just keep in mind the current chart does not have the NPI on it yet, but it still would fall under the Delta wiring or the Y or Delta wiring. Again, you know, rated for 3 to 1600 amps. Latest NPI allows you to provide 124 offerings in both 440 and 480 520 volt applications. And then coming soon, we are getting ready to do some extensions off of these to offer 178 DIN rail mounted part numbers. And one thing I do want to note here is, so the Y is 4 wires and the Delta is 3. A Y configuration, though, can be wired as a Delta by connecting the 3 phases to the appropriate lines and leaving the neutral open or disconnected. And I forgot to mention a little bit earlier here, but so the Delta, you connect the 3 phases and an earth ground, and then the Y is 3-phase earth ground and a neutral. So keep in mind a Delta cannot be wired to a Y, but a Y can be wired as a Delta if needed. So again, TE Corecom AC line filters. What is an AC line filter? Why do I need an AC line filter? And where are AC line filters used in factory automation? So again, kind of the whole scope of this, you know, an EMI filter is a device that suppresses conductive interference. Basically, to kind of keep it simple, I kind of compared it to an air conditioning filtration system, right? You've got dirty air in, use an air filter in your house to clean the air to go into the various rooms in your house. And the same thing happens with your electricity off the power grid. You get the dirty electrical power in, and then your AC line filters there to clean the electrical power out to protect your devices in that device. Or if it's coming out, it protects the device next to it from the power coming off that one device. So here's to kind of relate it to the AFGs a little bit, but for example, you know, you have a power grid, the 3-phase AC electrical power, depending on what country you're in, but typically in the United States, it's a 480 VAC system. So you have the dirty electric power coming off the power grid, going into a machine, or going into a factory, excuse me. As you can see, there's a whole bunch of electronic devices. These are just some examples of control cabinets that you'll see on like CNC machines next to a factory line controlling different motors, etc. So just to kind of get you a feel of where to look, the biggest picture on the left, if you see in the top section there, that big metal box, that is where the three-phase filter is located. And that three-phase filter comes before all the drives, the PLCs, the VFDs in the system, basically cleaning the dirty power coming into the system before it goes to the devices within that control cabinet. Next slide has some more examples on it as well. So again, you can see the three-phase filter there on the far right from the incoming power. Over there's a lovely Allen Bradley control cabinet with another three-phase filter and a PLC in there as well. So this is an example of a Corecom AC line filter in a control cabinet. And what I tried to do here is keep going another few clicks, Tony. I forgot there was this much animation on this slide. So when you're looking at a control cabinet and say you're talking to a customer and they say, I need a filter for this application. And as you kind of heard before, there's a little bit of fine tuning, but at a high level, you really need to know the power coming off the grid or coming into that device, whether it's single phase, three phase, and the current or the voltage rating. And then essentially what you're doing is summing up all the current that's being pulled inside that control cabinet to properly size a filter. So in this case, you see the power grid, you've got the 480 volt coming in, goes through the fuse or the circuit breaker and then the line contactor, and you have the filter down there in the left. And in order to size that, you kind of look at all the devices in there. So in this case, we have a PLC that's 2 amps. You know, drive 1 is pulling 8 amps, drive 2 is pulling 5 amps, drive 3 is pulling 3 amps. So essentially, you're looking at this, so you need a 480 volt filter that can handle 18 amps. So that's kind of how you really size a filter. Now, always keep in mind, I think best practice is to always try to size up a little bit, because you know, you might talk to a customer 1 week and all of a sudden you follow up with them again, you know, 2 months later, and they say, hey, you know, last minute the project manager had us change some stuff. We had to add another drive that's pulling 2 amps. So all of a sudden there you have 20 amps. So the fact that we launched this NPI with such a huge range of current ratings really allows TE now to be very flexible in design ends, where you are, based on the Corecom selector chart, you've already picked out a series and have that series designed in there, and then it's really just the very last minute sizing up the total sum of the current, accommodating for any kind of changes, but you still have that filter producing the same outcome. It's just rated for a different current. So this is a really high level elementary example, but when you guys are talking to a customer, that's pretty much how you can kind of high level size up a filter in the field right away. It's just the sum of the current and the voltage coming in. So real quick here too, kind of summarizing everything together to really focus on AFG applications and where the filters will go. So servo drives and VFDs here, Bob, as mentioned before, we do have some PCB mount filters that if you do have an application where you're working specifically on the servo drive or VFD itself, you could potentially use them on the PCB board. They are 250 volt VAC rated for 1 to 10 amps, general purpose, and they do have UL, CSA, and VDE approved. We also have the X, Y, and Z series. Same thing, 250 volts, 1 to 6 amps, and again, UL, CSA, VDE approved. But so just so you guys do recognize, we do have PCB mounted filters. Just feel free to promote those as well. Semiconductor machinery. So I don't have the full list of all the different products we have on here, but what I tried to do is, you know, in semiconductor machinery, you probably have 3-phase coming into the system, and then within the system, if you have a switching power supply, you could have some single-phase applications. But this is really just to kind of help get the ball rolling if you do go into a semiconductor machinery manufacturer on kind of some of the series you want to have maybe ready to go or promote right away. Again, they're Delta or Y configurations. different 3 methods of termination. That would be fast on terminals, ring and nut, and terminal blocks. And again, we have the 440, 480, 520 volt options. And same thing goes for the single phase products. These are just different, and Jay worked with me on this, different single phase products that we've historically seen gone into similar applications. But again, the real question is just 3-phase or single phase, and then what voltage are they at, and what is the total sum of the current being pulled on that side of the system. So again, a lot of this is going to be somewhat repetitive, because again, it really boils down to just whether or not the product is 3-phase or single phase. So you'll see a lot of the same series here, but warehouse equipment. There's probably a control panel controlling the motors that are moving the products down the line. And again, just 3-phase or single phase. So these are all just cheat sheets for you guys to carry around with you or to reference back if you're talking to a warehouse equipment manufacturer. Down at the bottom though, you will see the PEMs show up again, so the power entry module products. And I did put a picture here of some of like the forklifts, because we have seen these in the charging stations for the forklifts or the mobile robots that go around and pick stuff. You'll see a Corcom filter or a power entry module on the back side of that, especially on ones that are designed to be moved around the plant, where they can pick them up and move the charging station to one side and plug it into an outlet. Here's some robotics. Again, 3-phase products or single phase products. And here's kind of where the basic components of a robot. So if you remember that control panel example that I shared earlier. So we won't get into dual axis drives, but keep in mind there's probably at least one drive and motor controlling each one of those axes of rotation. So you have 1, 2, 3, 4, 5, 6 axes of rotation on this robot. So in that control unit or the motion power unit, you probably have a filter coming in that needs to be sized for the sum of all the different drives, the sum of the current that all those drives are pulling to size a filter up appropriate for a system on a robot or a control cabinet for a robot. And again, all of these options could be suitable for this application. It really depends on, again, where they're seeing the noise and how big of a filter that you actually need. So filters for lighting applications. Again, these are single phase filters, and we designed them for lighting applications, but they can also be used in other applications that involve single phase power. So again, industrial and commercial lighting, street lighting, outdoor signage, light drivers, and horticultural lighting. The FB and the FBL series, 277 VAC, VDC, have a 50-degree ambient temperature and then flying lead wire terminations. The newest one is the FBH series. So we did this based on some VOCs and from customers. High voltage was a big thing. So this now goes up to 480 volts, high ambient temperature, 90 degrees C rated, still the flying lead wire terminations. And then this is also for Canadian applications for 347 VAC. So these are some other examples that are slightly out of the AFGs, but I thought they were good visual representation. So here's an elevator example. So the incoming power, number 1 up there on the top, incoming power is 3-phase. So you would use a 3-phase filter there to clean the power coming in from the power line on the outside grid, but then also with all the electronics and everything, you could still see some noise some other places. So you have not only 3-phase for the incoming power, but in the control system, you would see single-phase product application. So if you're talking to an elevator manufacturer, right away, you could almost bring up both 3-phase and single-phase filter applications, because it does entail both. This is just an escalator example. So incoming power, 3-phase products. So down there, number 1, power coming in, it has the same setup as an elevator, the incoming power, and then you have the control system, which is usually done on 3-phase products. So again, just to kind of really show you different series that could be potential solutions in each one of these spaces. This kind of shows you what power quality is, and I'll just cover it real quick, but just know you'll probably be hearing from us relatively soon on this. But here's a schematic of power quality, and if you see that line filter there on the left side, basically this is the space that TE plays in right now. We primarily just touch on the power coming in and out of a system with the different EMI filters, but as you can see here, there's the AC line reactors, harmonic filters, DV, DT reactors, sine wave filters, and I guess the best way I can describe this is the fine tuning then of the electric signal for motor efficiency. Basically extending the life of a lot of the motors for companies by just fine tuning the signal. So it is something, I just wanted to share this with you real quick. We are looking at getting into it just so you kind of have an idea of what will be coming out in the filters group. But this is definitely something that a lot of the AFG applications, motors and drive customers will be very interested in. But then also just so you're aware of where we currently play in, which is just basically on the power line portion of it. So again, this is the whole Corecom EMI RFI filter selector chart, and if you take anything away from this presentation, just please always have a copy of this with you or know where to find it relatively quickly, because if you ever talk about filter applications, this is the best way to find a product series relatively quickly. And then you can get to a product series, and then of course always reach out to Jay, Sam, Meredith, myself if you have any questions to clarify. But you can take some time to look at it, but again, it's just yes, no questions that at least get you to a particular product series, and you can at least send the link to the customer. The copy that I gave you should have hot links. I didn't check all of them, but I checked quite a few, and all the hot links appear to where it can take you to the correct landing page with the series noted. But if you have any questions on it, please let me know. You also get this Corecom links. So the Corecom mantra back in the day used to be follow the line cord, which that mantra still exists today. If you want to find filter applications, just find where the power is coming in and out of the system, and that's where you will find filter applications. So still a very good mantra. There's some links here. So the Corecom catalog is extremely helpful. Corecom selector guide, you can use the selector guide, like I said, to get to a particular product series. And then in the catalog, as you saw with the P series, all of the part numbers here are smart part numbers. So each, in the Corecom part number, each digit or number or letter means something. So you can size up a product based on the termination method, the series. There's the elevators and escalators solutions link for the images that you saw there to kind of help refresh your memory if you want to think about, is it a three-phase, single phase, where would that go? Because overall in motion control, the applications, I mean, there's a control cabinet either on or away from the device that's controlling the motion. And then there's the horticultural lighting cheat sheet there, which shows some other products as well, but it shows a lot of the lighting filters, particularly the FBH series. And I think that's end of my presentation.